So this talk is about the short project post-quantum signature implementation using physical unclonable function. So this is a short project, SPRITE plus MD Secondment project. My name is Arnab Kumar Biswas. I'm a lecturer at Center for Secure Information Technology at Queen's Titanic Quarter at Queen's University, Belfast. And this was the project partner was Crypto Quantique. So it was a short project, but the main project objectives were mainly to explore integration of post-quantum cryptography with hardware-based security, then develop a hash-based post-quantum signature scheme using physical unclonable function, and also to enhance device authentication and trust. So mainly in this talk, I will try to give the high-level overview of this work without going into the much details. So what are the activities we have taken? So some activities are there are mainly two directions that I have taken. So one approach was to shift direction towards the full authentication protocol design instead of only one endpoint design. So full authentication protocol, which means this kind of protocol will have like initialization, registration, mutual authentication. So all different parts or components of the protocol. So that was the aim, and that initial exploration we did. And for that we integrated Sphinx Plus. So Sphinx Plus is that hash-based signature and PUF into this protocol. So this is one approach, and I'll give a little more explanation, some details. And the second approach that I was also taking, and in that direction, that is pure hardware implementation. So hardware implementation of one particular target was modular operation. So for modular operation, the main idea was that when we are talking about network security or end-to-end security, so at endpoint, which may have different types of vulnerabilities when you are talking about hardware security concept. So it may be necessary to have security from like a bottom-up approach, like a very low-level security features if we can have a secure implementation. So in this case, targeted for side channel attack. So this is secure against side channel attack, and this was the second direction. So as I said, that this is mainly to aim to enforce hardware level security at the node level, at the endpoint. But I will mainly keep my attention to the first approach, which is the protocol, the post-quantum security. So that is what mainly I will talk about. So, so the technical approach that we have taken for the protocol design. So we use Sphinx Plus, as I said. This is for the post-quantum signatures. So this is one of the main one, and PUF, that is physical unclonable function for device-specific key generation and challenge response pairs, and the protocol design for secure device authentication. So combination of both of them. That was the main idea. So Sphinx Plus. So Sphinx Plus is basically a stateless hash-based signature scheme. It is resistant against quantum attacks. So, that means this is a post-quantum cryptographic scheme, and it is already standardized by NIST. So it is standardized as post-quantum cryptography under the post-quantum cryptography standardization schemes. Regarding PUF integration, so PUFs, as you know, probably that it provide unique unclonable device identity. So at the hardware level, it provides some kind of hardware root of trust. So It provides, it is also used to generate the secure challenge response pairs, and it enhances resistance to spoofing and replay attacks. So that's about the PUF. So what that means that when we are talking about both, so Sphinx Plus offers, as we know, that it provides the strong post-quantum security, and PUFs provide hardware rooted trust. So the idea was that if we can combine and see what will happen in a protocol design, like is it possible, how much security we are getting. So that was the main idea, and initial exploration we have done. So that's the thing. So combined approach, it of course strengthens device authentication. That was the main idea. So so as I said, this was a initial design stage, and still we have not received all the results. So I can only say what kind of results we are observing, the main significance of those findings. So it provides, it points to some advantages. So of course, it addresses the main vulnerability for in the traditional cryptographic protocols. So we know the in case of quantum computers, so there are some vulnerabilities are there. So in traditional cryptographic protocols, so it provides that kind of vulnerability. It protects from them, and of course, it is also aligned with global shift to the quantum safe standards. Another set of points that we can observe is it demonstrates the feasibility of integrating PUF with the post-quantum scheme. So that I said that was the initial idea, that how can we integrate both, and what will happen if we want to do that in a protocol level. So that is what we are finding, that it is most probably possible. Still some analysis we are doing something. So yeah, but it looks very promising. That is what I can say, initial result kind of. And it lays the groundwork for secure IoT and embedded systems. So end-to-end communication point of view, where this is quite feasible. So that is the main part. So main motivation basically. So for future work, the in future the aim is to continue collaboration with the company Crypto Quantique, and we'll also try to seek some grant funding for extended research. And my also another aim was is to involve my doctoral student to in some future intensive opportunity with the company, if that is possible. So collaboration, we done some partnership with Crypto Quantique. We shared some expertise in PUF technology and some secure protocol design aspects. Some discussion we had initially, and we have some plans, of course, for long-term engagement also. So for the output, as I said, that the main work, the protocol or the post-quantum security and with PUF integration, that is still not fully over, still at the stage where we are gathering some data, then we need to think about writing. So the idea is that we want to have a publication, and it looks promising. So probably we'll go for some journal instead of conference. So that is the main idea. So on the protocol design and implementation aspect. And of course, there is always potential for commercial exploitation. But the second one, that is a smaller part, the hardware implementation, that modulo implementation, just one function implementation in hardware. So that I wrote a paper and it got accepted. So, but it is not yet happened. It will happen end of this month. This is IEEE SoCC 2025 conference. So this is one small paper. And of course, acknowledgement. So thanks to SPRITE Plus for supporting this Secondment, this project. And I appreciate Crypto Quantique also for the collaboration.